Right, introduction to Python. So if you ever opened your desktop computer, you'll see that this is the usual shape. This is the power supply, and there's a power cord coming out of it. How many of you here actually changed RAM or upgraded their GPU or something like that? Raise your hand. Okay. Yeah. So if you ever did that, you will be aware of the basic structure of a computer. There is the most important, most expensive part of a computer, which is the CPU. CPU is the name for the central processing unit. It's the brain of the computer. And there are two kinds of memories. So there's the storage, usually SSD drive, where things that you're stored in here in the storage, it stays even if you turn the computer off. But because the storage is slow, when you turn on the computer, when the operating system loads, what it does is it takes information from the storage and it starts moving to the RAM. Now, things in the RAM are closer to the CPU. It's much faster in terms of reading and writing, except that when you turn off the computer, things in here are gone. Okay, and in general, there are several other components like the GPU. You might have a Wi-Fi chip. You might have a USB chip somewhere. And all of these are soldered onto this thing called the motherboard. And over here are the bays for additional drives. So let's say you have a CD drive. It will be over here. Okay, but my point is that computers are different from humans. It cannot understand our language. What it actually understands is a bunch of bits, digital information, ones and zeros. So there's the memory address that stores all the information and also instruction sets. And all of these instruction sets mean something. So it's like load, regd, abc. This is like a human translation of what these instruction sets are. The human translations are called assembly language. Nobody programs in machine language directly. The closest thing we have is the assembly language. If you really need the computer program to be optimized as much as possible, then you would be writing in assembly language. But this is very inhuman. It's hard for us to understand what's going on when you see how this machine language operates. So what's needed is something called a programming language. A programming language is different from human language, but it's still something easier for humans to learn. And it's basically a bunch of commands you can give to the computer in human understandable form. But in between the programming language and the machine code, there has to be some kind of an interpreter. Okay? Now, you probably already know some names of the programming languages. Can you give me some examples of programming languages? Yeah? Java. Just say it. You don't have to raise your hand. Java. Huh? What? PowerShell. Okay, so that's kind of a programming language, but yeah, it's not full-fledged. Okay. Anything else? C++. Very good. Python we are learning. We just mentioned MATLAB before the class, right? What else? C#. Very good. Yeah. Do you know how to program on it? No? Okay. Anything else? Yeah, there are tons. There's the hottest language. Actually, if you know how to program in Rust, you can get good jobs right now. And there's the Golang, which is also pretty hot. In the data science world, the most common languages are Python and another language called R. And recently, there's this new kid in town named Julia that's also being used by many data scientists. Okay, so those are some examples, and there are tons more. Okay. There's even something called, forgot the name, it's Meow or, oh, ICANN has cheeseburger language where if you know that cat language, they kind of program with that. There are many fun languages out there that's not practical. All right, there are three types of coding languages. Things like Python are what's called an interpreted language. And what it does is every command is translated into machine language as it's run. So if you run the program, the code that you just made, then it will take line by line, translate, tell the computer what this means, and it'll be run. Now, that's going to be slow because you have to interpret all the time, right? So programming languages like C++ or Rust, these are what's called a compiled languages. What it does is it translates everything to the machine language before it's run. So when you compile it, it takes a long time, but once it's compiled and it's set into machine language, then it's blazingly fast. So a lot of times what happens is you program some easy stuff in Python because it's easier to program. But for compiled languages, you want to be more specific because there are many optimizations you can do. People do compilation because they want to optimize. So most compiled languages are a lot harder than interpreted languages. So you would make a prototype in Python, but then rewrite it in C++, and the speed up is something like 40 times the speed. If you are working in a big company handling very big software, compilation of a software might take a whole day, and that's when programmers play games or whatever. They can have chill when it's compiling. Yeah. It's a good excuse for programmers not to do their job. Okay, and there's something in between. There's something called just-in-time compilers. Who knows an example of a JIT language? Anyone? Java is an example of a JIT language. I don't know much any others. I think Julia and also JRuby, those are JIT languages. So what those do is it compiles to an intermediate language. We call it bytecode. And the bytecode is stored and it's compiled just before it's run. Now, you might ask, why do it in two steps when you can just do it in one step? The difference is that there are many different kinds of CPUs, right? Some of you have Apple computers which run on M1 chip, M1 CPU, or M2, M3, that series. Your phones would have Snapdragon CPUs or something like that. Nowadays, there's the AMD and there's the Intel, and all these different CPUs have their, there's a common language, but there's also some native language where it optimizes some things differently. And because of that, if you have a JIT compiler language, what it does is it takes the bytecode and changes to the most optimized version for that system. And because of that, sometimes JIT compiler written programs might be faster than the compiled ones, but I doubt it's not that faster. But it has its own reasons. Okay. All right. So those are the three. But you just have to remember that Python is interpreted, so it's slow. Some of the extensions of Python, like NumPy, you're going to see some other packages in Python. And those packages are internally written in C++. Those are compiled, and the library simply calls those compiled functions from Python. So sometimes even if it's written in Python, it might be using a library that's fast, so it's not going to be that much different than running a compiled language. Okay, Python is made by Guido van Rossum, this person, in the early 90s. It's easy to learn, most popular language for data science and machine learning. So machine learning is a bigger field containing AI. And most of the engineers here will be doing some sort of a capstone course at the end, making these automated vehicles and stuff. And because those products will need AI to maneuver, you will most likely be using Python to do that thing. Okay, so you will be probably using Python language once again just before you graduate. Okay, so it's very powerful, and it's right now the most popular programming language. Yeah, it has many things called libraries, which are extensions of the language to do many complicated operations with ease. Okay, so now what I want you to do is everyone go to the Spider. I asked you to run this before this class, but if you haven't, please turn on your computer, go to the search box on the bottom left, type Spider. You will see the Spider installed. This is the Anaconda version of the Python. If you install the Anaconda version of the Python, the Spider will automatically install. Now, when you run Spider, you'll see that it has two panes. Actually, there are three panes. Let me see. Yeah, so there will be three panes like that. Although some people like the variable explorer and other things on here, I don't like it, but you can leave it there. I don't like it, so I'll just delete this pane so that it's easier for you to see. Okay. So on the left side is where you can write down a full program. I'll show you how to use it later today, but in the beginning you will most be using this right side. Okay. Now what I want you to do is to go through this ritual for everyone learning a new language. So regardless of what languages you're learning, C++, R, Java, anytime you learn a new language, you learn how to print hello world. It's like a ritual for every programming learner. So we're going to do print quotation. It can be a single quote or a double quote, it doesn't matter. So quote hello world exclamation mark, and quote and parenthesis, just like that, and hit enter. What do you see? Yeah, congratulations. Now you officially know how to program in Python. All right. Now what I want to explain to you today is the concept of a variable. So let's type this, MSG equal to hello world exclamation mark and quote. And then this time, instead of printing hello world, we're going to ask to print MSG and enter. Same result. Right? What's happened here, please make sure that you're typing as I do the lecture. If you don't type, you're not going to remember what's done. Okay? Make sure that you type all this. So let me explain what happened. So MSG is what's called a variable. And variable is like a box. So when we executed this command, nothing got printed. It doesn't seem to respond at all, so you think nothing happened, but something actually did happen. What happened was Python internally is creating this box, naming it as MSG, and in that MSG, it's putting the information hello world. It's storing MSG into this box named MSG and putting the hello world. That's what's happening. That's why when you ask to print MSG, it looks up the MSG and finds out that inside the MSG, this is the message to be printed. It prints out the message. Pretty neat, right? Okay, if you're curious to know whether MSG has anything, you can type in MSG and enter. It will say that it's hello world. That's what's in there. Now you can do other things with Python. There are other types of variables. You can do a equals to 1, and then say a plus 4, and you get 5. Obviously, right? A is 1, and 4 is another number, and it's asking 1 plus 4. You could have done 1 plus 4, it will do the same. Just like your TI calculator, multiplication is star. If you wanted to know 7 times 5, it'll give you 35. So you can use Python as a quick calculator, which is sometimes what I use it for. So if I need to, like when I'm calculating some expenses, I have like a bunch of numbers, bills to add. And if I can't quickly do it in my head, I will just open up the Python and add them up. Sometimes it's slightly more involved. I need to calculate something like 20% of not $100, like $178.78. I need the 20%. Then I would open up Python and do this. So it's useful as a calculator. And then if I say B and enter, it complains. What's the error message? B is not defined. How do I make the error message go away? We will have to assign something to B. So B is not yet created because I didn't assign anything to B. So if I do B equals 1.3 and ask what B is, it says it's 1.3. So now it knows what it is. Okay, probably the most confusing part of variables is the following statement. So first, what was A again? A is 1. Now if I say A equals A plus 1, nothing happens. And if I ask what A is, what would that be? 2. It's 2. Okay. And this confuses a lot of people because, first of all, A equals A plus 1 makes no sense. There is no number that's equal to 1 more than itself, right? Can you think of any? No, there isn't any. But not only it doesn't complain, what it does is it calculates what A plus 1 is, so 1 plus 1 is 2, stores that number into A. So that's what you get. And what that tells us is that equal is an assignment operator. So maybe I should update my slides. Some facts. So equal is an assignment operator. Make it bigger. And it is not the equal in math. Now, if you want the equal in math, we use equal equal. Is the comparison operator. So let me show you how that one works. So you have, if I say A equal 1, it will say false. Now, what should I do to make it say true? A equal 2, right? It will say true, right? Okay. So it says false or true. By the way, false and true are what's called a Boolean value. So let me see. If I say C is equal to false, it lights in blue because it's like a reserved word. You cannot, so for example, I cannot say false equals to, I can't store 9 into that because false is a reserved word. Okay. But these variables, it can be a single letter or it can be many letters, just like how we did it like this. You can title it anyway. As long as you don't put quotes in there, it will think of it as a variable. All right. Now, so far we have the following variables. MSG had this in the content. A had 2, B had 1.3, C had false. Now, these are all variables. It's storing something, but they are different types. So we can ask what type this is. So first of all, if I ask what MSG type is, it says it's a string. Okay. If I ask what type A is, it says an integer. If I ask what B is, it says float. And type of C would be Boolean. Okay. There are a few more like lists and dictionaries that, but they have different types. Right? So variables have different types, and these are str for string, the int for integer, and float for float. And there's something called Boolean, named after a mathematician named Boole. Boole is the name of a mathematician, and is it she or he? Can't be sure. But this mathematician made the system of like calculating with true and false. So that's Boolean. Now, what's a bit different than other languages is that in Python, all variables are objects. Okay. Now, a new word. What's an object? Objects have data and methods or functions. So methods are internal functions. So for a while, people had variables by themselves, and then things you can do with the variable, like the addition, multiplication, all these things you can do, those are called functions, and we had them separate. So in languages like C, you have a separate thing for variable, another thing for a function. But you can also do dir of A, and it will give you all the kinds of things you can do with an integer. Now, some of these have underlines, which are usually not for us to use, but they also have something like this. Okay, so let's see. So, for example, what is a dot bit length? It's a function. It'll say it required 2 bits. It also has imaginary real, and these are for being able to be used with some other data types. There's the complex data type. And then if you use with the fraction data type, it can also give you numerator, stuff like that. Okay, I actually never used these, so I don't know much about these methods, but for strings, there's a, if I do dir, MSG, strings you can do a lot more. So for example, you can make everything uppercase, so msg.upper, you see this command here, upper, and if you execute this, what it does, it made everything uppercase, right? You can also make it as titled, which will only make the first letter of a word as upper. And we'll eventually find how to use these other ones. These are used more frequently. Okay? All right. So let me just update this to put those two in. So type variable tells what type the variable is, and dir variable shows shows all the available methods of the variable object. Okay. All right, and then let me just add a little bit more. You can have something called an F string. So, so let's say something is, so A is equal to 150. And I want to say B is equal to F quotation. Try this one. This machine costs, open a brace, put the A, close with the curly brace, close the parenthesis. Maybe I should put a dot there. Okay. We do that. And now let's see what B has. What happened? It replaced the curly A by the value in A, right? Yeah. So sometimes this is useful. So there's another command called input. So input, let's see, A is equal to input, how much is it? Right. Oh, sorry, I forgot to close it. You can do double quotes. How much is it? If I put like 175, in A there's the number 175, and then you can do print. Here is dollar curly brace of A, and what it will do. Oh, I forgot to put the F in front. That's how you do the F string. So if you don't do the F, then it just prints verbatim. Okay. So if you put a F, then it's 175. And now we are able to use this left pane with something to interact. So we're going to say A, or we can just copy and paste. So we're going to copy this here. A equals to input. And then print F. Then you can run this. And if I say $2,000, I'll say here is $2,000. Okay. So that's your first program. See how it's nice to have something on the left side, and you have it on this right side. Well, let's use Claude. So Claude. Okay, so I'm going to say write a story of first day in college. Okay, let's see what it does. Okay, so you can copy this. Mad Libs, yeah. Who said that? Oh, thank you. Yeah, Mad Libs. So basic idea is Mad Libs, and what you want to do is you want to say text equals to this thing, okay? And the nice thing about having triple quotes is that you can have many lines. And you can make this into any story that you want. This is too generic. It's not that fun. Okay, then we can put this later, and we can start by saying input. So place. Okay. Give me a place. Okay. So that's going to replace this. By the way, you should definitely put an F string here. And then you can feeling input. What kind of feeling? Okay, just like that. And then let's just delete everything. Let's do feeling. Okay. And then thing, input, name a thing. Okay, I'm pretty sure you'll be able to make this more interesting than what I have. So. I don't like this. He ran because he was embarrassed, or something like that. Okay. So you have this, and then it's triple quotes, okay? And I have a very short one, but I'm pretty sure you guys can be creative and make this longer. You can also find some Mad Libs, but don't try to use existing ones because it's not that fun. Please try to make something with the help of AI, and then change things like this. Okay. So now you print txt. Let's run it. See what it does. Okay. Give me a place. Where? Store. What store? Walmart. Feeling. Energized. Okay. Name a thing. A pile of cans. Okay. Something like this, and then. Oh, I should really print something before. So print. One of the things that you can do in print is like if you do \n, it gives you a bunch of new spaces. So if you do that, if I run it the same way, if you put, say, this time target, and what kind of feeling, sad, and then name a thing, fridge. Yeah. Okay, so it doesn't make much sense, but it can be made to be more funny. All right, so I'll make a summation place in the bright space, and this will be your first homework. Okay, so try to make something like this.